Hey everyone, Dave here. So in this video I want to go over continuing on our basic NEP-5 token here. So in the last video we did our total supply, name, symbol, decimals. We haven't done our balance of or transfer yet. Nor do we have a way that tokens ever get created. So right now we say there's 1,000 tokens, but no one possesses them. So that's what we need to do today, and that's what we're going to cover. So what I'm going to do here is I'm going to create a custom action on here. I'm going to call it deploy, and I'm actually going to call a method. Called deploy. So I could put my code right in line in here if I wanted to. It makes it a little ugly to work with, so I'm just going to have it call a method. Now what deploy is going to do is it's actually going to create these tokens. Well, I shouldn't say create them, it's going to give them to someone here. So if, well, let's see here. So we're going to start using this storage system. So this is a namespace that allows us to store data on the blockchain and retrieve data off the blockchain here. So we want to put something into storage here. The first parameter this takes is a storage context. So for us, right now, we're going to use the current context. This means that for this contract's storage, you can actually access other contract storage. So this is great if that you have two contracts and they need to be able to read information about each other. You could actually access that information. I've never done it, but that is why you always have to pass this parameter in. Now it's going to take in a key. So this key can either be a byte or a string. So here, what we want to do is we want to take in, well, I guess we want to give this to an account here. So I'm going to put owner here. We'll kind of cover that in a second. And then the value. So in the value, we'll take a few different things. It can take a byte, a string or a big integer. Big integer is a type that holds large numbers. Obviously, I guess by big integer, but and then so we're going to put in the complete supply. So now it's complaining that it does not know who the owner is. Static read-only owner. Sorry, this is going to be a byte array. You can obviously tell that is not valid syntax. But I'm going to take this address here, and I'm going to put that in there because addresses are easier to work with. But what NEP-5 tokens are actually going to work with is the script hash of the address. So there's a nice little helper method called toScriptHash. So that'll take an address and convert it to a script hash, which is just a byte array here. And you can actually see that script hash is if you go view contract, you can see that script hash here. And then I have to fix my casing here. So when the deploy method gets called, it's going to put 1,000 to this owner's storage here. Well, it's a storage of the contract, but the key is the owner's address here. Now we're going to do a few things here. For one, I'm going to have this return a Boolean. And it's going to return true. The other thing I want to introduce here is some helpful stuff here for logging information. So I'm going to do runtime.log deployment complete. So let's build this contract again, and we'll run through the typical routine here. I'm going to do it as fast as I can now. Let's give this a few seconds to be ready. There we go. So what I'm going to do is I'm going to run the deploy. I'm going to test it. So you'll notice here the gas consumed was 1.16, which is a lot higher than our other contracts we've dealt with. This is because storage.put operations are very expensive. So you want to minimize how much data you're storing on the blockchain, which is good for the whole ecosystem. And I'm going to invoke that because it's actually changing something here. So what I'm going to do is I'm going to jump to here, and it actually has a bunch of stuff from another contract I was working on earlier. But you can see here that tutorial coin, there was a type of log, we'll get into notify here shortly, deployment complete. But then you'll see this again. Now we only deployed it once, but it appears here twice. So this, I should mention, this tab is only because we're using NeoGUI Developer. This is not available in the regular NeoGUI. So this is where it becomes handy. The reason we get two messages here is because this one was from when we did a local invoke here. So let's do, actually I don't want to do it, yeah, I can't do a deploy. Let's see here. You see the second I click test, we got a new line here. When I invoked it was when it actually happened on the blockchain, and the GUI developer picked that up in the new block, that log message, right? So now we've got that. Now we need to be able to get the balance. I shouldn't have closed the GUI developer there, but so balance of is going to take a parameter, right? When this contract gets called, it's going to pass a parameter here that will be the byte array of the script hash that we're trying to get, right? So script hash comes from the address. Hope that's clear. So args bracket 0, but it is a byte array, and all we know is that it's an object, so we are going to have to cast it. I'm going to create this method here. So it's going to return a big integer. It's going to have the byte, and this will be the account. So because we did a storage.put for the information here, I'm just going to copy that up here, and we're going to just tweak it a little bit. So here I put a storage.get, again our current context, and then the key I passed in to do the lookup is the account. Now what storage.get returns is a byte array, which is not a big integer. Big integer has an overload that can take a byte array in. And I might as well demonstrate to you here. Runtime.notify. So runtime.notify takes in an array of objects. So we're going to say retrieve balance, comma, account, comma, balance from storage. Okay, build that again. Fire up the NeoGUI developer. Open my wallet. Deploy the contract again. No, wait here. So we can look at this block number if we want here. So it was at 38. So at 39 here, we should be included. So 32 here. Actually, what I'll do is I'll pop this event log open here. So here we're going to call the BalanceOf method. And because this one does actually take a parameter, we're going to add that parameter here. So this is going to be the script hash of the account that we want to query. So script hash is actually a hash 160. I'm going to paste in that script hash here. So NeoGUI developer again has these options in here. Otherwise, you're going to be treating most stuff as just a byte array in the regular NeoGUI. So this does kind of help. I'm going to test this here. And we got a VM state halt break. Everything was fine. The gas consumed was not that high. And the evaluation stack was a byte array with a value of blank. The reason this is blank is because we have not deployed yet. So we've not put those tokens into the owner's account. Now, what I want to show you here is the notify message. Retrieve balance / here is the basically hex encoded result of that script hash / the amount that we retrieved, which is nothing. So let us go. Oops, I don't want to deploy the contract. So one of the handy things here too is there's this little search button. So if you've already searched for a contract and found it, you can just put it back in there again and just click on it. So this will be the last thing that we deployed. So I'm going to call our deploy method. You could call it initialize, you could call it whatever you want. You'll see here that again we got this log deployment complete, but it actually didn't manipulate the blockchain yet. Okay, so now that is done. BalanceOf. Grab this as a hash 160. You could also just put byte array in here if you want and decheck hex encode. It doesn't seem to like it, maybe because of the preceding 0x. But here, I'll just put it in. So here, now there's a byte array with some information in it. We should actually just match that from our earlier video, but again, we can decode it. There we go. So that is implementing a deployment and getting the balance here. This deployment is a little insecure in that there's a few problems with it to start with, is that anyone can call the deploy method. And what that deploy method would do would automatically put 1,000 tokens into the owner's account. Luckily, we're not taking a parameter in here to say who gets the funds. And so basically what I could do is I could sell off my 1,000 tokens and then just call deploy again and generate a new 1,000 tokens, even though that's more than the total supply. Now, community will catch on pretty quickly that I'm spending more than there is supply, and we'll have, hyperinflation on this and it'll be worthless. So there's a few things that we can do here. One is to, first of all, check to see if deploy has been run. So the best way to do that is to, I guess I shouldn't say the best way. One way to do it would be to put a key into storage saying, let's call it deployment complete with a value of true. Oh, it does not like that because it cannot convert it to a byte. So I'm just going to put a number in there, 1 for true. Storage.get right, so it is a byte array. We can try accessing it. I've never done this before. Actually, that could be a problem here. Because if there is no record in storage, it's going to return null here. So let's do this. So I'm just basically checking to see if the deployment complete key has ever been set before. I don't really care what the value is. This could be anything we want it to be. We're just checking to see if that key returns anything. So the first time this is run, it should not have anything in there. The second time it's run, it should have something in there. So we should not be able to double deploy. So we will try that out. We will wait for this to deploy. There we go. So we're going to invoke this here. Oops. While we're waiting for that to invoke, we will get set up to deploy the next time. See what happens. So we can see here that the second message came in saying that the deployment was complete. If I test this, you'll see the message we get is cannot deploy, deployment already ran. And if we invoke it, it's going to actually go to the blockchain, cost us actual gas, but not really do anything. But we can check what our balance is here. Just get balance of. And we're going to pass in our script hash. So our deployment has run twice. I believe that was the same number we had earlier. It was. So it did not double deploy. So in this case, we don't really need to secure this method here, because if someone from the public called it, it wouldn't do anything. It's already got this check in here to make sure it cannot be double deployed. Now, the case where we may want to secure something like this is, let's say we're installing this contract on the blockchain and we want to wait a month before we actually credit the funds to certain accounts or this account. So I want to introduce to you how we're going to do that, even though it's not super necessary here, but we're going to start using this right away. We're going to use this runtime.checkWitness here. CheckWitness verifies that the person invoking this contract matches this hash or public key. So hash would be our script hash or the public key of the person calling it. For most stuff, you're going to use a hash. The public key isn't really used by too much, but it does have its place. So what I'm going to do here, save myself a little time here. So what this will do is it'll say runtime.checkWitness, and then we pass in the owner's script hash here. So that says if the caller coming in is not this person, it's going to log this information here. So again, build, and we're going to fire this up because I guess I exited it. We're going to deploy the contract. And one of the things I just forgot to do was copy down that script hash. So what you can do is reload this window here, and it will generate the exact same script hash, as long as you've not changed the underlying contract and recompiled it, because that would generate a new script hash. So what I want to do is I'm going to create a new wallet here. So I'm going to call this, let's put this up into here, non-owner. I'm going to give it a very simple password. I'm going to copy this address here. So in order to invoke any contract, even though there is no real gas costs for the most part, you still need to have gas in your wallet. So I'm going to need to do a little transfer here as well. Oops. Just gas should be fine. We'll give 100 gas to that account, will be more than enough. Okay, back to non-owner. Hopefully I did not screw that up and my NeoGas will appear here on the next block. There we go. So now as the non-owner, let's try doing a deploy. So even with this test here, I'm going to see you are not authorized. But just to make sure, I'll test it and I'll actually invoke it on the blockchain. So this was our first test, second test. Wait to the next block. So there we go, you were not authorized here. So if we switch back to the owner, and we invoke this contract here as the owner wallet, you'll see here that we see deployment complete. And then we'll invoke it to actually run the contract. Okay. Now, when you run this, you may actually see something a little bit different here because I've customized my NeoGUI developer, and I'm not sure if it's a stable change yet here. And what you normally get when you do a test is the transaction does not get signed by the wallet, so it does not know who the witness is, who the caller is, when it runs it through the VM. So when you actually click this test here, you may see you are not authorized in your log because the local VM doesn't know who you are. So funny enough, the code is actually right here. I'm taking the, in the invoke contract dialog, during the test, I'm actually using the current wallet to make a transaction. And then instead of passing TX into this application engine, I pass the wallet TX into here. If you want to try it, you're more than welcome to. It's helped me a lot. I haven't found any issues with it. I don't know if there was a reason it wasn't done to start with, but just letting you know, that's why you may see something different and you may get tripped up by that, because I know I spent a bunch of time trying to figure out why it kept saying that I was not who I said I was and access was denied until I actually ran it on the blockchain with the invoke and got a different result. So there's your gotcha of the day. And I think that's all we'll cover for now. Next video, let's start getting into actually transferring it so we can move these funds back and forth. So thank you for watching.